This is the Turf Zone Podcast, your central information and news hub, bringing together professionals from turf associations across multiple states to share things to help you in your business. Brought to you in partnership with our friends at the Virginia Turfgrass Council. This episode is sponsored in part by Sod, world-class service on demand. Visit us online at www.buysod.com. Now, let's get in the zone.
Welcome to the Turf Zone. In this episode, we feature an article titled, Boosting the Buzz in Your Backyard. Ornamental plant choice impacts the abundance and diversity of insect pollinators in gardens. Margaret J. Couvillon, Assistant Professor of Pollinator Biology and Ecology, Department of Entomology, Virginia Tech. This article is based upon the following peer-reviewed study: M.C. Palmersham, R. Schurch, M.E.O. O'Rourke, J. Slezak, and M.J. Couvillon. If you grow it, they will come. Ornamental plants impact the abundance and diversity of pollinators and other flower-visiting insects in gardens. Horticulture 8, number 11, 2022, 10 through 68. Plants are mostly stationary. Although they can move a little bit, growing upwards and outwards, these movements are small, slow, and generally insufficient for finding a mate, especially if you want to reproduce sexually every year. Sexual reproduction helps maintain genetic diversity in a population and is a winning strategy. Therefore, over millions of years in coevolution, plants have solved this sessile challenge by developing close relationships with some animals to serve as the vectors to transport pollen, the male sex cells. That close relationship is pollination, and about 88% of all flowering plants need that animal assist to make the magic happen. Of the animals that participate in pollination, insects are by far the most consequential. If we line up the plants, both wild and agricultural, that need pollination services, our heavy lifters are insects, such as bees, butterflies, and flies. Therefore, while birds and bats are also valuable in this process, there's a critical need for the contribution of insect pollinators. The large role of insects in plant reproduction makes their recently recorded declines even more alarming. Insects in general and pollinators in particular are decreasing in numbers, abundance, and species richness, diversity. These declines have been precipitous, upwards to 75% by some measures, and likely a reflection of the larger threats to wildlife in general that humans have bequeathed to our world. For insect pollinators, of course, their declines have direct consequences on our global food security, as 75% of food crops need insect pollination services. Both wild and managed insect pollinators, like honeybees, face challenges from pesticides, pests, pathogens, and poor nutrition, where a lack of abundant, diverse flowers in a landscape can have direct and indirect negative consequences on insects. Media and popular press coverage has been wide. Everyone wants to feed hungry pollinators. One activity that is immensely popular among concerned citizens is to establish a pollinator garden, where ornamentals are planted with the express purpose of feeding pollinators. Groups ranging from schools to libraries to museums to private individuals are frequently approaching perceived experts, that's an assistant professor of pollinator biology, for advice on what plants to use. When I started receiving such phone calls in 2017, I realized that all I could do was direct people to existing plant recommendation lists. I quickly realized, however, that a non-specialist gardener, such as myself, might experience barriers against making informed choices about plants for pollinators. For example, recommendations from organizations like Xerces Society publish lists that appear based on expert opinion, but lack empirical backing or do not cite sources. There are also inconsistencies among plant recommendations where there is very little overlap, even within regions. Sometimes recommendations are too general, even if we know that different cultivars might vary as much as tenfold in their attractiveness to insect. Additionally, some recommended plants require greenhouses for growth from seed, which would definitely be a challenge to someone like me. Lastly, some gardeners might want to target butterflies, while another, next to an apiary, might wish to cater to honeybees. I was discouraged by the lack of available data and existing recommendations, so I decided to make my own, targeted to our mid-Atlantic region, but hopefully also useful to gardeners everywhere. Fortuitously at this moment, my lab was approached by Kaiser Compressors, whose USA office is based also in Virginia, because they wish to commemorate the 100th anniversary of their parent company, Kaiser Kompressoren of Coburg, Germany, with an environmentally focused project benefiting the communities they serve. With Kaiser's involvement in the food processing industry and recognizing the pollinator crisis' broader impact on the world's food supply, it seemed a great fit. Plus, it didn't hurt that their corporate colors are yellow and black. With the backing that they gave and with the help of two colleagues, Dr. Scroggins and O'Rourke, from another department on campus, we recruited a new graduate student, Mickey Palmersham, and started planning. We broke ground on our experimental gardens in September 2019, wrapped up the field portion of the project in August 2021, and graduated Mickey a few months later, and published our research in a peer-reviewed journal in 2022. It's been a wonderful journey that has resulted in a tangible product that we hope will be useful to others. In our study, we designed, planted, and monitored 2 experimental gardens in Blacksburg, Virginia for 2 summers, 2020 to 2021. One garden was located at the Urban Horticulture Center, and the other was located at the Turfgrass Research Center, both affiliated with Virginia Tech. With these gardeners, we investigated the effects of 25 ornamental landscape plants readily available in nurseries on flower-visiting insects. Plants were either native or non-native to the mid-Atlantic of the USA, and they were either perennial or annual. We surveyed the number of taxonomy of insect pollinators through non-destructive sampling and analyzed the data to determine the plants that brought an abundance and diversity of insects to gardens. Our goal was to provide everyday gardeners with data-driven recommendations to help them create customizable, pollinator-friendly gardens. Over the 2 summers, we observed 26,804 insects, a majority of whom were from the insect order Hymenoptera, mostly bees, but also some wasps. We also saw butterflies and moths, flies, beetles, and some grasshoppers and crickets. We could not identify some insect visitors with our methodology, but these were a small proportion of our data. What did we find? First and foremost, plant choice matters on both the abundance and diversity of garden insect pollinators. Our most visited plant in terms of numbers, the black-eyed Susan, had a 42-fold higher abundance than our least visited, the petunias. Actually, our top 6 plants in terms of insect abundance, black-eyed Susan, brown-eyed Susan, and Joe Pye weed, purple coneflower, Helen's flower, and sedum, all received on average more than 90 visitors per plant plot, with the top 3 as true prize winners, with a whopping 200 plus visitors per plot across a year. And what about diversity? Did the same plants that brought high abundance also bring high diversity? There was some overlap, as the top 6 plants were purple coneflower, zinnia, Helen's flower, yarrow, catmint, and dwarf goldenrod. We looked at this more formally, and we found that the plants with a middle score of visitor abundance tended to have the highest score of visitor diversity. In other words, the plants with very low or very high abundance had the lowest diversity. We do not know the exact reason why this might be, but one possibility could be that if a plant was particularly good, especially in terms of collecting efficiency, for one type of insect, that insect might overwhelm abundance and deplete the resources, discouraging different diversity visitors to then come. Did plant lifespan, whether it was annual or perennial, or plant nativeness, whether it was native or non-native, impact the abundance and diversity of visitors? In terms of abundance, there was a clear answer. Native perennials outperformed non-native perennials and non-native annuals. For diversity, perennials, both native and non-native, did better than the non-native annuals. These results are not too surprising, as previous studies have generally characterized perennials as better than annuals because they have many years to accumulate resources for feeding pollinators. One thing important to remember is we are not saying that annuals are without garden value. Many, although not all, of them possess little to no foraging resources for insect pollinators. However, they are some of the easiest flowers to grow and provide long-term color aesthetics, providing beauty to a garden. For the wildlife-conscious gardener, their addition can be balanced against the inclusion of other, more rewarding plants that do provide foraging resources for the hungry insect pollinators. Our study was necessarily limited to our selection of ornamental plants, which of course is a mere slice of what is potentially available to gardeners, and we would expect different results with different plants, cultivars, or maybe some variation across locations and seasons. However, our results do clearly show that choice matters, and the inclusion of some of these easy-to-grow, easy-to-find plants might bring a boost to the buzz factor of your garden. In fact, as part of our original research article, we included tables with our insect counts and plant cultivar information. This will allow for plant selection that targets specific insect taxa, allowing for customization in a way that was missing from other plant recommendation lists. The article is open access and therefore freely available to anyone that wants to take a look. So if your thumb isn't as green as you would like, but you still wish to create a beautiful garden for both you and insect pollinators, let these plants be your guide. You can optimize for flower-visiting insects in a data-driven manner to create a splash of color that also helps to feed the hungry bees. For all resources associated with this article, check out our show notes. Don't miss an episode. Subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. You can also visit us at theturfzone.com.
You've been listening to The Turf Zone. Thank you to our sponsors, including Buy Sod, world-class service on demand. Visit us online at www.buysod.com. For more episodes of The Turf Zone, visit theturfzone.com and subscribe on Apple Podcasts, Stitcher, or your favorite podcast app.